Hey, hi everyone. This is Ashish here. Today we'll be talking about apply function in Pandas DataFrames. So this is a very relevant function when it comes to applying different functions to rows of the data frame. So we can actually have it in three different ways. So either we can use the dataframe.iter rows, which will actually iterate through each row one by one and then apply that same function to every row. So this is a earlier method, and I think this is the from performance point of view, this is the worst method to apply because this will take too much time to apply the same function to all the rows one by one. It won't perform any vector-wise operations to speed up the process. So the second method is traditional. We can define a traditional Python function and then use the apply function to pass that function to the data frame so that the complete functionality can be done in a vectorized manner in a much faster way. And the third option is actually second and third are the same. So instead of writing a separate function to complete the functionality, what we can do is we can just pass it on as a lambda method. So I think I've just made a mistake here. So it's lambda function, and I'll just show you how do we do it in three different manners. So let me first import the relevant libraries. So I'll just import the pandas as PD, and then I'll just read the data frame df pd.reads in this way, which is inside my data folder. Sorry, okay. Data Titanic train.csv. This is a public dataset which I've downloaded just for the demonstration purpose. And now we have and then coming back here, let me just show it to you how this dataset looks like. So we have basically these many columns. One, we have the passenger ID and then whether they survived or not. And then the P class basically refers to the passenger class, and name, sex, and age. And then this is basically referring to the number of siblings or spouse accompanied in that particular ship. And then here we have, I think, parent and children's. Yes, number of parents or children's. Yeah. And this is ticket number, fare, cabin, and the city from which they started their journey. So for our purpose, I think we can use any of them just for the demo purpose. Let me just use, let's say, survived. We'll change it to a different value if the survived is 1 and to a different value if the survived is 0. So the method 1. So we'll actually write a for loop in which we have, let me show it to you how actually what exactly is returned by df.iter rows. So if I say for row in df.iter rows print row, sorry I missed it here, yeah. So here you can see we have a tuple basically. The first one basically refers to the index value which is here, and the second element actually refers to the actual row. So to capture the actual row, what I can do, I can just write another function here, another parameter here for I comma row, and then I can access the row element using just by row. So what I need to do now is I need to check if row of, I need to pass in the column name on which I'll be modifying, and then survive. If it is equal to let's say 1, what I need to do is I need to update the data frame for that particular, so for that particular row which I can access by the index, and then column name is survived equal to, let's say I'll name it as OK. So he's safe, or okay, whatever. So now if I just run it and then try seeing the data frame, see, now we have changed this. So since this is a very small portion of the data set, we didn't see much performance issue, but if it is a very big data frame, you can definitely see the performance difference. So this is the first method we have completed, and the second method, the traditional Python mentions. So let's define a function. Def, let's say name it as increment class. I want to upgrade the class, so we should accept a parameter, and then if x equal to, let's say if it is equal to 1, then I need to upgrade it by 1, x plus. So I need to return x plus 1, else return x itself. No need to change anything. So this is a simple method I have written. So how do I apply this function to all the rows of this particular data frame on this particular column? This is the column I want to apply now. So now I just first need to select that particular column, because I'll be updating this particular column, and then equals to df of the class, sorry, dot apply, and what I need to pass it on is the function name, this one. So basically what this does is basically it will just consider each element of this particular data frame. So every time this dot apply will be a vectorized operation. So this function will be applied to each row of this data frame. So one at a time. Let's say assume that one element of this is going inside this. So this x will be coming from this particular data frames column. So every time the x will be assigned to one particular row. So for the first time when it will be evaluated, the x value will be 3. Then it will go inside this and come here. It will check x equal to 3. No, equal to 1. Sorry, equal to 1. This is false, and then it will come here and then return x. So it won't change anything. And the second time it will come as 1, and then it will pass, and then it will increment, and then it will go like this. It will go on. So if I just pass it on here and then just complete this, and now check the data frame. Now you can see for all the value rows where it was 1, it got incremented to 2. For all the rows where it was 3, it did not do anything. So that's the second method. So the same apply method, since this is a very simple logic what I want to apply on this particular data frame. So this is, you can see this is almost 3 lines of code, 3 to 4 lines of code. So I can do the same thing in a single line of code. Let me show you how. Here we can leverage the lambda functionality. So now I can do df of, let's say I want to, okay, let's switch back to survived column. Let's say wherever it is 0, I'll just print it as not okay or not safe. So if I just select that column and then df of survived dot apply, I'm applying that function on this particular column. So I'll select the column first and then dot apply. Then what I need to do, I need to write the same logic in lambda function. So if you're aware of this lambda function, how this will work is, this is just an inline function. So lambda x, so the same parameter x, I'll pass it on here, lambda x, then colon, this is the syntax of that particular thing, and now the new value, I want it to be changed as not okay. So when do I need to change it to not okay? Only if the x value is 0. So if x equal to 0. So let me show you once how, I mean, right now this will actually throw an error. So let me show you that. See, it will give you invalid syntax because we actually should write the else part also to complete this lambda function. Since we are missing the else part, it gave that error. So if x equal to 0, it will be not okay, else I don't need to change it. So else x. Now if I run it, it succeeded. Now if I print it, So yeah, see, now I got just got chance to survive to not okay wherever it was 0. So what we saw in this particular video is three ways in which we can actually apply a function to all the rows of a data frame. Method 1, either we can use df.iterRows. This method actually is very helpful when we are actually manipulating the rows individually. So let's say for few rows only we need to modify certain things, and I'll make a separate video on this one, how can actually this method be very helpful in certain situations. But for this particular situation, when we are actually trying to apply the same function for all the rows, the fastest way is this dot apply, because this will be a vectorized operation, not a row-wise operation. So the second method was just to define a function and then pass the same function to dot apply. And the third one is basically the same, but instead of writing a separate function, we just use the lambda expression to use it. So yeah, if you have not subscribed to my channel, just subscribe it, and then feel free to add a comment how you felt and what exactly is missing, so that we can cover in the next videos. Yeah, thank you.